In this video, we're going to learn about rapidly prototyping interfaces in Android Studio. Specifically, we're going to build a working calculator. Android Studio is pretty cool in building UI. It supports two ways of doing this. First is a what you see is what you get drag and drop interfaces where you can bring widgets over to your interface. And then on the back end, there's this declarative XML interface, and you can customize your interface using either paradigms. In addition to that, we're going to show you how to hook up the interface to Java using things like click listeners. So there's four primary things that I want you to learn about. First, using built-in widgets like grid layouts, buttons, and text views in Android. And grid layouts are important to all interfaces, but you can tell from the examples I have on here of the calculators in iOS and Android that they're basically built using grids. The second thing is we'll learn about interfacing between the drag and drop, what you see is what you get Android builder, and Java code. For example, we'll hook up click listeners. Then we'll perform some basic styling, and along the way, we'll learn about Toast and some other quick tips. All right, let's get started with the demo, and then I'll show you how to build this. So in the foreground here, we have an Android emulator, specifically a Nexus 4 device running Ice Cream Sandwich. So let's just try out a few different equations and see what happens. We'll start with 1 plus 1, which should obviously equal 2. We can clear this. We can do more complex operations and equations like 4 times 3 plus 3, which should be 15. We can then divide that by 3 to get 5. We can multiply by 10 to get 50 and clear it. There's also some simple error checking. So if I try to do 5 times, you get this little toast message that pops up that says you cannot enter two math operators in a row. So again, if I try to hit a plus here, I'll get a slightly different error message, or a divide. So 5 times 5 equals 25. Okay, so let's see how to build this. To show you how to build this calculator, I'm going to walk you all the way from the beginning, starting a new Android Studio project, to the end, making and testing the interactive calculator. So let's start a new Android Studio project. Let's call it CMSC 434 calculator. CMSC 434 is the undergrad class I teach in human-computer interaction at the University of Maryland. And the rest of this stuff, we can keep the defaults. So for the Android API, we're going to go with Ice Cream Sandwich rather than something that's more modern like Marshmallow, because it's supported on 97.3 of the Android devices in the ecosystem. And we'll do an empty activity, and we can keep the defaults for that. Now we wait. So we have an error here. It says rendering problems, exception raised during rendering. So we can go, that's because it's selecting this automatically pick best Android N. We're going to go to Android 6. And so we can see that everything is working well here. So the first thing we should always do is start out by just running the basic activity. I already have an emulator running. That's the emulator you saw before, which is this Nexus 4. So let's just see what an empty project looks like and make sure that it works. So here it is, hello world. So we can stop that. All right, now let's actually build our interface. The template code that Android Studio adds is this text view and this hello world. We're just going to get rid of that, and then we're going to start to build our calculator interface. And to do that, we're going to start out using the what you see is what you get Android UI builder. So the first thing we want to do is add in a grid layout, because we're going to use that as the backbone of laying out our entire interface. And Android is really cool in how it supports this grid layout. So we can actually drag and drop interface widgets over here. So for example, this button. And as we do that, notice how it gives me the properties of row and column in real time. So let's lay this button down right here, which it's now in row 0 and column 0. And we can look at the text of this button. So here's the button. Here's your grid layout, and this is the declarative XML interface, so we can switch back and forth. So for example, if we want to switch this button to row 1, we can do that, and then we can go back to the design and see it here. Now we can put another button into row 0, column 0. Okay? And that's basically how we're going to build up this grid over time. So you'll get the hang of it in a second. The thing that we need at row 0 is basically our text view, the calculator screen. So we're going to try to build this part, and we'll do that first. So for this, I'm just going to use a text view. So let me delete this button. I'm just going to put in a text view. And I find that it's easiest just to sort of, as you're rapidly prototyping this, just sort of drag and drop interface widgets over and then kind of worry about configuring the sizes and other properties over time. Switch over to the text view. We can see the screen text view that we just added and this grid layout. Let's call this ID text view screen, our output screen. Okay, and then for the text, initials text, we'll set it up as 0. So these properties you can actually set in the designer as well. So I have that text view selected, and you can scroll down to text and you can see that it has 0 here. And then in terms of its ID, which is important when we're interfacing in Java, text view output screen. Okay, so now we're going to do the same thing with these buttons. So the first button is going to be our clear button. All right, let's go back and look at our example calculator interfaces. So we're going to actually put a clear button up here, just like iOS does. So for that, we're going to name it button key C. That's the ID. And then for the text, we'll do C. Now there's going to be a blank spot, and then we're going to, up here, we're going to put the divider. So again, we'll change the ID, button, key, divide. All right. And we're just going to build up the interface like this. So here, this button here is going to be button key 7. Go down to text 7. And this one will be 8. And this one will be 9. So we'll add in all of our numbers here. So we got to go back and set the ID for this button. Key 8, button key 9. So I have 7, 8, 9, 4, 5, 6, and 1, 2, 3. So let's do that. 4, 5, 6, button key 4, button key 5, button key 6, button key 1, button key 2, button key 3. All right, and then we'll go and set the text for this. So this is 4. This will be 5. This will be 6. This will be 7. This will be 8. This will be 9. All right. So we also have to add in some more operators, and of course the number 0. So we're going to basically follow this. We're not going to use the decimal point, but we're going to add in a 0, an equals, plus, minus, and a multiply. So let's do that now. That'll be our 0. This will be our equal sign. So this one will be our multiply. This one will be our subtract. This one will be our addition. This one will be our equals. And then here, this one will be 0. Oh, let's set their IDs. So let's do that. Scroll back up here. Button key 0. Button key equals. Button key add. Button key subtract. Button key multiply. Let's just double check what the actual XML looks like. You can see the IDs are all set. Button key divide, and then the rows and the columns, and all of that is automatically set for you. So we're going to have to do a couple of different things to make this look a little nicer. So the first thing is, if we click on this text view, it's only going in one column, and we want this text view to actually span 4 columns. So this is pretty easy, actually. There is a property that we can use to allow it to span the four columns, and it's called layout column span. So we'll scroll up. So here we go. So we have row span and column span. So in this case, we want it to go across all 4 columns. So there we go. And the other thing that we want to do is have like the 0. I think it looks nice if we have that span too. So we have that span too. Now notice it doesn't actually fill that. So to do that, we have to work or set up the gravity. Gravity pushes, this gravity property pushes the interface element in the direction that you set. So top would push it up, bottom, left, right. So it's basically like this alignment, and in this case, we're going to have it fill horizontal. So there, now we have the 0 filling. So we basically have the whole interface now. With the exception, we want our text view to be slightly larger than this. Okay, so for this, we can do layout, gravity, fill, both. Now we have a large text view. So we've basically set up the interface widgets for our calculator app in mere minutes. Now that we've set up our UI, the basic structure for our UI, we have to make it interactive. And for this, we're going to actually write some Java code. So if you're unfamiliar with input listeners or input events in Android, I suggest that you Google, and specifically you can go to the input events documentation in Android. We're specifically going to be looking at buttons. And buttons are unique because they have on-click listeners. So when you click on them with your finger, they create a click event. So there's two main ways to hook these up. The first way the documentation describes is via Java, and the second way is via XML. We're actually going to go through these in reverse order. So we're going to start with the XML version because I find it easier. So let's just choose a button that we want to listen to for a click. So in this case, we'll do the clear button, which is C. So we'll go here, Android on click, and now we'll use a function name, on button click. Oops, we'll do lowercase for the method. Okay, now Android Studio is smart. It says method on button click is missing in main activity, so we have to add it. Okay, so for that we do public void, and I know what the signature is. You could just consult the documentation for this, which is right here. Public void, the name of your method, and then it takes in a view object. So let's do on button click, because that's what we called it, view v. And remember from class we said that view is the top level UI object in Android. So Android Studio knows that we have to import this class, so you can hit Alt Enter on a Mac or on a PC to bring this up, and automatically imported that. And so we're basically good to go. Now when you click on that button, this function will be called. I'm going to use something called toast to show a quick message that this button had been clicked. So we can do toast.makeText, and you have to give it a context, so just do get application context, the message itself. So we'll call this XML hookup button clicked, and we're going to cast this view object as a button because we know that it's a button. Get text. Okay, and we'll import the button class. And then the final thing that's necessary here is the duration. How long this toast message is going to show up for. All right, so that's all we'll do. We'll now run this code. All right, so let's hit this button. It's not working here. Button C. So if I click on C, the toast message should show. It's not showing because I forgot to do something, which is, if you go back to Android Studio, it actually tells you, toast created but not shown. Did you forget to call show? And indeed I did. So we'll stop the application and do .show here. And I just want to emphasize again that we've only hooked up an on-click listener to one button, which is button C. Okay, so let's run it again. Okay, so now let's try it again. And there we go, XML hookup button clicked C. Okay, the reason why I prefixed this message with XML hookup is because I want to show you another way of hooking stuff up. Oh, and if I click on other buttons, nothing happens because these are not hooked up, okay? So I'm going to do one new thing, which is I'm going to stop this. And we'll just add in this to the next button, which is to the division button. And then we're going to do something different with this button. With the 7 button, we are going to make a programmatic link. So for that, we're going to do, we're going to grab the button. And in this case, we do this find view by ID. So what did you call it? Remember we want button 7. There we go. We're looking for a button, find view returns a view. We know it's going to be a button, so we'll cast it. All right, And now we have to hook it up. So for this, set on click listener, and we're going to make an anonymous class. That implements on click. All right, and again, we'll just copy and paste this toast message. This same will say Java hookup button clicked. All right, so now we'll run this. Now we have button 7 hooked up in Java, and we have the C button and the division button hooked up from this XML interface. Now we'll run it again and just check and see what happens. It's a little bit confusing because the last instance is running here, but you can watch your debug window here to see. You see it's installing the new code. It's starting it here. So just quit the last instantiation. Alrighty. So if we do C, it'll show XML hookup button clicked C, division, XML hookup button clicked division symbol, and then 7, Java hookup button clicked 7. All right, so we have a lot of buttons. So I'm going to show you a little bit of a shortcut. Because we have so many buttons, I kind of want to hook them up automatically. So let us do that now. So we will stop this, and I'm actually going to... All right, cool. So this is stopped. So I'm going to hit the home key here. All right, so I'm going to remove these on button clicks. Remove these on button clicks. I'm going to remove this. And I'm going to make a private class called button click handler that implements view.onClick listener. And this is going to handle all of our button clicks. All right, so it has to implement. All right, so now it's following the interface on click. Okay, so now we're going to put all of our stuff in here. All right, so I said I was going to make a shortcut. All right, so rather than grabbing the button and setting the click listener, we're going to do something slightly different. All right, I'll just comment this out. Paste the toast message in here. So that's what we had before. We have a ton of buttons. So this is just a quick little shortcut, and hopefully it'll make sense. And it's something I think you can use in a lot of different powerful ways. So the first thing we're going to do is we're going to get the grid layout, because that's basically our container for all of our UI widgets. And we do this in the same way that we grabbed our button, but we just use a different ID. Oh, in fact, I forgot to name it. So let's name the grid layout. And we'll just call it grid layout calculator. All right, so now we have the grid layout, and we're going to ask the grid layout for all of its children, essentially. So grid layout dot get child count. And then we're going to iterate through all of them. And if it's a button, we're going to try to hook it up to this button click handler. So button click handler for equals 0, I less than count, I plus plus. All right, and then we will get the view v equals grid layout get child at. And then we'll check to see if that view is a button. If it's a button, then we're going to hook it up to our listener. If v button, then view dot on click listener button click handler. All right, this code alone hooks up all of our buttons to this click handler here. So now let's run the code. And this is basically just a shortcut so that I didn't have to set up these click listeners in every single button. I could have done that, you could have done that, it's fine. But I just think this is a bit more powerful to do it programmatically. Okay, now all buttons should be hooked up. So you can see that here. All buttons have been hooked up. All right, so the next step is now to actually set up some calculator handling. So we're going to get some input and some operators, and then we want to display a result. We haven't done that yet, so that's the next step. All right, so the first thing we're going to do is we're going to capture the click, and then we're going to add the key that was pressed to our output screen. So let's comment out this toast, and I'm going to write a little bit of defensive code here. So I'm actually going to just check to make sure that the view that caused this click is a button, and it should be. All right, so now we're here. Let's just cast it as a button. We could call it click button. Oops. Okay, so well, the other thing that we want to get access to is our text view. We could call this text view output screen. All right, so text view. 1 second. I'll enter. There we go. And we have to find view by ID, r.id. I think we call it text view, so we'll call this button clicked. All right, so now this is pretty simple. We're just going to keep concatenating the output screen. We'll test that to see if that works, and then we'll start working on the actual calculations. So text view output screen dot set text. So we're going to do this append. So we'll do dot get text, which returns a character sequence. So we'll do toString plus button clicked dot get text. All right, so this, we're going to run this. All this is going to do is take the text of the button and put it in the output screen, and it's just going to keep concatenating over time. So we'll run this. So we'll try it. 7 should get appended to this 0. It's just going to keep appending. And then C won't do anything. It'll just add C there. So there's two things to notice, I guess. The first is, since we start as the default state of 0, we should handle that sort of separately. So if you press a key and all that the interface shows is 0, we should do something different. And the other thing is for C also needs special handling. So let's add that code right now too. All right, so if v.getID, lots of different ways you can do this, but I'm going to first check to see if the button that was selected was the clear button. So for that, we'll do r.id.button key C. So if that's the case, then we're going to set our output screen to 0. In fact, we can move this up. Okay, so that should handle the case where we do clear. Okay, so we also want to handle this null state. So if you hit a key and the screen only shows 0, then we should do something slightly different. So for this, we're going to check the text view output screen dot get text dot equals 0. So if that's the case, then we actually want to set the screen to nothing. And let's see how that works. So we've hooked up the clear button, and we've have this concatenation behavior when we press buttons in the calculator with a special interaction for when the screen is 0. All right, so we could try 5, and you can see the 0 goes away. 6, 7, 8, 9, and let's try clear. Clear goes back to 0. All right, so we've actually got quite a bit of behavior that we want. I am going to do something to make it easier for you to see the screen real quick, and we'll come back to this when we talk about styles. But I am going to set the text view size to something larger so that you can. So Android has text size as a property, and we'll set it in these. Let's see, I don't know, 50 SP. Something like that. All right, so now that's much bigger. Okay, that'll be easier for you to see what I'm doing. All right, so now we're going to actually start to do some calculations. So we're going to add in a new class. We're going to call it calcutils. All right, calcutils. And this is going to be basically a static class, so we don't want anybody to make this. It's just going to be a utility class. So we'll also do final so that nobody can extend it. And the first thing we want is public static is operator character. All right. This is going to check to see if it's a mathematical operator. Whoops, return Boolean. Okay. So I've already written this function. So basically checks to see for the division symbol, which I have 2 symbols for that, multiplication, subtraction, or addition. So I'm going to switch this condition up a little bit. So if it's equal to 0 and the current key is not an operator. This way we can do 0 plus something or 0 times something. And the calcutils, the other part of calcutils is going to be taking a string and parse it and return the result. And for this, you can Google around. There's lots of different math parsers online. The one that I'm using is actually from Stack Overflow. So let me just copy and paste it in here. And I've posted this online as well, so it'll be in the GitHub, and it'll also be in the YouTube comment, a link to the Stack Overflow post. All right, because we've actually got to do the calculation now. That's the next step. Now we want to hook up the actual evaluation functions in calcutils and provide some of the calculator behavior. So we have to check to see if the equal sign has been pressed. That's what's going to invoke this calculation. So we'll check here if the equal sign has been clicked, and if that's the case, we're actually going to try to calculate our result. So we'll get the contents of our screen. Run our results, and convert it to a string. So that should work. Now, we haven't done any error handling here, but I just want to run it and see what happens. It looks like there might be an error in calcutils somewhere. Let's see, we'll make the project and see what happens. Let's make it again. We have to change the variable to string. There we go. So we should be good. So let's try 5 plus 5 equals 10. So we have basically the entire calculator working right now. We just need a bit more error handling. So if you recall, I added in this special condition here to handle if the state of the output screen is only 0, or the state of our equation is only 0, and the next button to be clicked is an operator, we don't clear it. So we can do 0 plus 9, for example. That's what this little addition does. All right, so we'll clear this. I want to show you a little bit of error handling that we don't have yet. So we could do 9 times, and then we could do another operator like division, and then a number, and try to do equals, and it's going to crash. Okay, so there's 2 things that we're going to do here. One is we're going to handle the error ourselves and let the user know that there's a problem. And the other is we're going to do a try-catch block, just in case there's other errors that we didn't expect that happened. Okay, so let's do the try-catch block first. And again, we're going to do a toast, and then we're going to reset the state. So there was some exception that happened, so we are going to put the screen back into a default state, so we're going to set it to 0. Okay, so now we're going to handle the case where the user presses a math operator twice, like plus plus, or a multiplication symbol and then an addition symbol. And to make my code more readable for these error checks, I'm going to switch around the control flow a little bit. I'll just do a simple refactoring. We're going to put this inside of here, and here is where we're going to check. So I'll write in a few comments here, okay? Check for the clear button. If clear button pressed, set calculator screen to 0, reset. Here, check for the equal sign. If pressed, then calculate our results. And then here we will check if 2 math operators pressed in a row. If so, show an error message using toast. All right, so let's implement exactly what I said. Else if the text view output screen is greater than 0, and the last thing in the output screen is a math operator. So we'll do and calcutils dot character at length -1, So that will be if the last thing in the calculator output screen is a math operator, and the current button pressed, current button clicked, get text. The current button pressed is a math operator, then we have a problem. And we'll put all of this stuff into an else. All right, so for this, we will set up an error message. So string error message, something like you cannot enter 2 math operators in a row. You entered show them and then we'll show this using toast. Well, maybe we'll do length long because it's an error message. Show. All right. So now we actually have some error handling in here. So let's check to see that that works. All right. So let's try 8 times 8 should be 64. Okay. Let's clear the screen. Let's try 6 plus 6 should be 12. Let's do 6 plus plus. You cannot enter 2 math operators in a row. You entered plus and plus. So there we go. We may want to have a period at the end of the sentence, so I just added that. I do 9. So basically we have all the functionality here. The next step is to do some stylization. So I already did a bit because I changed the default font size of this text view, but we're going to do a few other things. Maybe we'll draw a border around the output screen and we'll increase the size of the text in these buttons. All right, so let's do some of that stylization. We'll stop here. All right, so I already showed you how to change the font size, and we could do that. We could change the text size of all these buttons. So for example, this button C, maybe we don't want it that big, but we could maybe make it 20 SP or something like that. And certainly we could copy and paste this across all of the buttons. That would be fine. But we're not going to do that. Instead, we're going to make a style and that we can apply to all of the buttons. So we'll go over here, res, values, styles, and we're going to make our own style for these buttons. We'll call it calculator button. And then we're going to have a few different properties that are set up to be the default. So the things that we share across all the buttons are wrap content. So we'll move that in there, and we'll set up a text size. We'll set it to 20. So the way these styles work is you make the property name here, and then the value here. So now we just have to apply it. So I've set it up for 3 different properties of buttons, and we just have to apply it. And for that, we go back to our activity, and we're going to make style equals at, we just have to reference it now. I think we called it calculator button, right? So there we go. And you can see it's already reflected here. So we can remove the wrap content from our other buttons and just set up these styles. So now any style that we want change we can make in this styles, and it'll be applied to everything. It's a bit like CSS in classes. There's also inheritance and all sorts of fun stuff. You can Google about it. Last one. Now, the other thing I wanted to do is add in a border around this, and as it turns out, it's not super simple to do that. I Googled around and I figured out that there's a number of different ways to do that. So when I Googled, I found this Stack Overflow post, how to put a border around an Android text view, and someone nicely summarized lots of different methods to do this. So we're going to use the first way, using a shape drawable. So we can basically copy and paste this. The only thing we have to do is we have to put it in drawables. So we can call it anything we want. It just has to be an XML file. And we'll call it calc screen border.xml. And we'll change these to being actual colors. And the border will make black. So it should show the preview right here. Oh, I see. Right. There we go. So it's doing a live update here. So we could say change this to red, then the red border. But we're not going to have it be a red border. We'll just, well, maybe we'll make it blue. So it's RGB. So we'll make a blue border. And then we have to add it to our text view. So we're going to add that as a background. So and let's click off of it. You should be able to see that it's a border. Oh, and then we should set up the padding a little bit. So let's do that. We'll go back over to the designer and then because now that we have a border, it looks like it's sort of too close. Maybe we'll set this to being 4. Yeah, so now that's better. All right, now we've styled it a little bit. Let's rerun it. All right, finally have our emulator. Okay, so we have this nice like blue border. Actually, I don't really like blue. I think we should go back to black. All right, there's black. 8 times 8 is 64. Let's do, oh, I just noticed this is 7. Aha, that is a problem. All right, let's go back and fix that. That should be 1. Let's see, button key 1, there we go. It's almost the whole time I had the wrong number there. Oh, and I have it wrong for the whole bottom row. All right, let's fix that really quickly. 1, 2, 3. All right, now we have it. Okay, so let's try that again. We have 1 plus 2 plus 3 should be 6 times 9, 54, divided by 9, 6. All right, perfect. So we have our whole interface that's done. Let's go over what our learning goals were. Using built-in widgets such as grid layout, buttons, and text view, interfacing between the WYSIWYG interface and the Java code. We performed some basic styling, and then I also showed you Toast and a few other tips on how to rapidly prototype code. If you were already familiar with some of these things, I think you could have built this calculator in probably between 6 to 10 minutes, assuming that you also had the math parser. All right, great. I'll be posting the code to GitHub with some links in the YouTube comments.